In this video, we are going to study how to find the present value of a lump sum. First of all, let us understand what is present value. The present value is the current value of a future sum of money or a stream of cash flows when a specific rate of return is given. That means an amount of money we earn today is not the same as the same amount of money earned in the future. If we earn 100 rupees today, it is worth 100 rupees. But if we earn 100 rupees after 5 years or so, it is not same as 100 rupees earned today. For example, suppose we can buy a chocolate for rupees 5 today. After 5 years, we may not be able to buy the same chocolate for 5 rupees. Maybe the value of that chocolate has increased to 10 rupees. So, if we have got a job now and we earn 100 rupees, with that 100 rupees, now we can buy 20 chocolates. But after 5 years, we are in the same job and we are earning the same 100 rupees. Then, with that 100 rupees, we may not be able to buy 20 chocolates. Then, we have to reduce the number of chocolates to 10. With the same 100 rupees, today we can buy 20 chocolates. After 5 years, we can buy only 10 chocolates. Just half. That means the value of money is decreasing. So, if we are going for a job and earning 100 rupees today, after 5 years, we should not choose this job because the worth of this job or this salary is less. After 5 years, we may prefer a job with a higher salary. Instead of 100 rupees now, then we have to get 200 rupees. Then only we can buy 20 chocolates. That is the difference between present value and future value. Now, we can calculate the present value of an amount earned in the future. This can be done in three cases. The first case is to find the present value of a lump sum paid or received after a specific period. And the second case is where equal payments or receipts are made at regular intervals. That means 1000 rupees or 5000 rupees, same amount is either paid or received every year or every month, like that. And the third case is unequal payments or receipts at regular intervals. That means, suppose first year we are paying 1000, second year we are paying 2000, third year it may be 3000, like that. The payments are not equal as in second case. Here the payments are unequal, but it is done at regular intervals. In these three cases, we can study how to find the present value. In this video, we are going to study the first case. In the case of lump sum paid or received after a specific period, how to find the present value. Now, let us check out the formula to find the present value of a lump sum. The present value PV is equal to FV divided by 1 plus I the whole raised to N. And in this formula, PV is the present value, FV is the future value, I is the interest rate, and N is the number of periods. Instead of using this formula, we can also use the formula to find present value in the case of a compound interest. That is, P is equal to A divided by 1 plus R by 100 whole raised to N. Both of these formulae can be used to find the present value. Now let us take an example. Rupees 100 to be paid after 1 year when the expected rate of return is 5% compounded per year. What is its worth today? So we will get 100 rupees after an year. What is the value of that 100 rupees today? 1 rupee earned today is not like 1 rupee earned in the next year. Thus, there will be difference. We have to find that difference. So, what all things are known here? The future value is 100. 100 is earned after 1 year. So, that is the future. Therefore, future value is equal to 100. N is 1 year. And I is the rate of return, that is 5%. So that is 0.05. Now apply it in the formula. PV is equal to FV divided by 1 plus I raised to N. PV is equal to 100 divided by 1 plus 0.5 raised to 1. That is just like 100 divided by 1.05. Hence, the present value of 100 rupees is 95.24. If we earn 100 rupees next year, it is the same as we earn 95.24 rupees today. And our next problem is to calculate the present value of rupees 50,000 to be received after 5 years, provided that the compound interest is 9%. Let us see what all things are given in the question. The future value is given as 50,000 rupees. Now, how do we understand it is a future value? Let us read the question once again. Calculate the present value of what? We are asked to calculate the present value of what? Of rupees 50,000 to be received after 5 years. So we are going to receive 50,000 rupees after 5 years. That is a future period. That is why 50,000 rupees is the future value. And we are asked to calculate the present value. Now N is 5 years and I is 9%. That is 9 divided by 100. So it will be 0.09. Now, let us apply these values in this formula to find the present value. So, present value is equal to 50,000 divided by 1 plus 0.09 whole raised to 5. That is equal to 50,000 divided by 1.09 raised to 5. Hence, the value is 32,497.1. This means that if we earn 50,000 rupees after 5 years, it is just like we earn 32,497.1 rupees today. Thus, we have to understand that 50,000 earned after 5 years is not like earning 50,000 today. Its value is decreasing. If we earn 50,000 today, it has got the value of 50,000. But if we earn 50,000 after 5 years, it has got only the value of 32,497 rupees today. And next, let us check out a different type of question. Initial investment in a project is 1 lakh. At the end of first year, 50,000, and at the end of second year, another 50,000 are invested for its growth. What is the total present value of investment if the expected rate of return is 15%? So, what all things are given here? I is 15%. That is 0.15. And what else do we know from the question? It is given that initially, that is today, a person is investing 1 lakh in a project, and after 1 year, he is investing again 50,000, and after the next year, that is after the second year, he is again investing 50,000. So, what is the total present value of the investment? That means he is investing 3 times 1 lakh today, next year 50,000, and the next year again 50,000. And we know that 50,000 invested in the first year is not like investing 50,000 today, and 50,000 invested in the second year is not like investing 50,000 today or in the first year. All these are different. Let us compute what is the difference. So the initial investment is 1 lakh. Since it is done today or now, that is 1 lakh itself. Its value is 1 lakh itself. Then at the end of first year, that person is investing 50,000 rupees. Let us find out what is the present value of this amount invested in the future. Future means after 1 year. So the formula to find the present value is FB divided by 1 plus I raised to n. By applying these values in the formula, 50,000 divided by 1 plus 0.15 whole raised to 1. This 1 is 1 year. After 1 year, the second investment is made, and that is 50,000 divided by 1.15. So, present value is 43,478. That means when he invests 50,000 rupees after 1 year, it is just like investing 43,478 rupees now. And now let us check what happens after that. Again, at the end of second year, he is investing 50,000 rupees. Now this will not be same as the one invested in the first year. Let us find the present value of the 50,000 invested at the end of second year. That will be just like 50,000 divided by 1 plus 0.15 whole raised to 2. So here it is done after 2 years. That is why we are taking 2 year. Then that is equal to 50,000 divided by 1.15 whole raised to 2. So that is equal to the present value is 37,807. Now see the difference. 50,000 invested at the end of first year is 43,478 and 50,000 invested at the end of second year is worth 37,807. So it is just like investing 1 lakh plus 43,478 plus 37,807 today. That is the total amount he has invested is 1,81,285. Now the same problem can be solved using another method. Here we have solved using this formula. PV is equal to FV divided by 1 plus I raised to n. Instead of using this formula, the present value factor table can be used to solve these problems. All the problems solved in this video can be also solved using the present value factor table. In the present value factor table or the discounting factor table, the values of discounting at all the percentages for 10 years are given, and from these we need only to select the required percentage for the required year and multiply with our value. Thus, we are not using this formula now. Without using this formula, let us try to find the solution to this problem. So, we have to find the present value factor from this table. Let us see how to find the present value of these values. Let us take the first one, that is 1 lakh. 1 lakh is invested now. Present value of 1 lakh is 1 lakh itself because it is invested now. Hence, there is no need to find the present value again for 1 lakh. Now, let us check for the next investment. The next investment is done at the end of first year. 50,000 is invested at the end of first year. So, it is not done now. It is done after 1 year. Thus, there will be difference in the value. We have to find the present value of that investment done at the end of first year. For this purpose, we can use the present value factor table. The percentages are given as column headings and the number of years are given as the row headings. We have to choose the right column using the percentage and we have to choose the right row using the number of years. Here 50,000 rupees has to be multiplied with the present value factor at 15 percentage for 1 year. So we are choosing the column of 15 percentage and row of 1 year. That element in the 15 percentage column and first row is 0.8696. So 50,000 into 0.8696 is 43,480. That is the present value of 50,000 invested at the end of first year. Now coming to the 50,000 invested at the end of second year, the same column we have to choose in the present value factor table because the percentage is not changing. It is 15 percentage itself. So 15 percentage column we have to select, and instead of the first year row we have to select the second year row. That is the second row. The value in the 15 percentage column for the second row is 0.7561. So 50,000 into 0.7561 is 37,805. So that is the present value of 50,000 invested at the end of second year. Now let us see the total investment or the present value of all these investment together. First 1 lakh, present value of 1 lakh is 1 lakh itself, and then the present value of first year invested 50,000 is 43,480, and the present value of 50,000 invested at the end of second year is 37,805. So the total present value of investment is 1,81,285. This is the same value that we got while doing in the other manner. Now, let us take another problem. For the marriage of two daughters, Ram requires rupees 50,000 after 4 years and 60,000 after 6 years from now. How much money he must deposit in a bank paying 10% compound interest per annum? That is, this RAM requires 50,000 after 4 years and 60,000 after 6 years from now. So, what amount invested now will bring him 50,000 after 4 years and 60,000 after 6 years? That is the question. So, we have to find the present value of 50,000 now. Only then we can invest that amount now. Present value of 50,000 has to be invested now. Only then we can get 50,000 after 4 years. And the present value of 60,000 has to be invested now. Only then we get 60,000 after 6 years. So the same formula let us apply. Even the present value factor table can be used here. But here we are going to solve using the formula. PV is equal to 50,000 divided by 1 plus 0.1 raised to 4. This is the first case. He has to receive 50,000 after 4 years. So we have to find out what amount should be invested now. So in the case of first daughter's marriage, he needs only 50,000 rupees. So this may be applied as such. Then 50,000 divided by 1.1 raised to 4, that is 34,150. So if we invest 34,150 now, we get 50,000 after 4 years. So we can suggest Ram to invest 34,150 now so that he can get 50,000 rupees after 4 years. Now, what should he invest now for getting 60,000 after 6 years? There is the second case for the second daughter's marriage. The same formula can be used, and that will be 60,000 divided by 1 plus 0.1 raised to 6. That is 60,000 divided by 1.1 raised to 6. Hence, the present value is 33,870. So, he has to invest only 33,870 now to get 60,000 after 6 years. So, totally he has to invest 34,150 plus 33,870, that is 68,020 rupees. Now, if he invests 68,020 rupees now, he can get 50,000 after 4 years and 60,000 after 6 years. So, that is how we find the present value of a lump sum. There are two methods. First method is using the formula and the second method is using the present value factor table. Thank you for watching this video. For more videos, you can subscribe this channel.